Okay, so this video is me going over basically the whole semester. So I'm going to break it up into several videos, obviously, but I'm going to try to tell you which unit each question comes from, so if you want more questions like it, you know where to go. All right, so number 1 is actually from Unit 6. So the number off to the side is what unit it's from. Okay, so Unit 6, it's actually Unit 6, Lesson 5. We just got done with it, the very last lesson. Okay, so in GHK, GH is 7 and GK is 15. Write an inequality that describes the possible lengths of HK. So this is the one where the shortcut is basically just add these and subtract these, and that's your inequality. So subtract them, you get 8, and you add them and you get 22. And the reason that is because the two sides have to be longer than the third side. So if 15 is the longest, then 7 plus 8 is 15, so it has to be bigger than 8, which is what that is. If 15 is not the longest and the missing side is the longest, 7 plus 15 will be 22. So the next side cannot be any more than 22. It can actually not be 22, but there you go. Okay, so number 2, find the perimeter and area of the composite figure. This is Unit 1. I think it was lesson 6. I think it was 1-6. It's in that region. Definitely Unit 1. To find the perimeter and area, first we'll find the perimeter. So I'm just going to add up all the sides. Well, to do that, I need to find all the sides. Well, there's that one's 7, so we can assume the other one over here is 7. This is 14, so this is over here is 14. And this whole thing is 18. And it says that these three pieces are equal. Those are all horizontal pieces that can, if you add them all up, they would equal the whole thing. So 18 divided by 3, each of those is 6. So now I'm just going to add everything up. So 18 plus 14 plus 6 plus 7 plus 6 plus 7 plus 6 plus 14. I'm just going to grab a calculator. And I get 78 feet. The area you could do a couple different ways. I'm going to do the area of the whole thing, and then I'm going to subtract the cutout, the area of the cutout. All right, so the area of the whole thing is 18 times 14. The area of the cutout is 6 times 7. So you just got to multiply and subtract. So 18 times 14, the whole thing would be 252. Minus 42, I'm going to get the area is 210 feet squared. Okay, and if you didn't realize this, I'm going to set it, but the answer key is the last page. So I'm going to make sure I'm doing these right by, yep, okay. Multiple choice, which diagram shows a point P as the center of gravity of the triangle? So this is lesson 6, or unit 6, lesson 4. Okay, this is center of gravity is the centroid. Centroid is made by medians. So I'm looking for medians that meet in the middle. So medians would be D. And I know they're medians because they go from a vertex to the midpoint of the opposite side. I know it's the midpoint because of the markings. Okay, this is not midpoint because it does not come from the, these are midpoints, but they don't come from the vertex, so they're not medians. Those are perpendicular, not necessarily midpoints, and those are angle bisectors. Okay. Number 4, that's unit 3, lesson 2. Which lines, if any, can you conclude are parallel given the measure of angle 1 plus the measure of angle 2 is 180? So if these two add up to 180, which two lines are parallel? It's J and K, but if you can't see that, what two lines make angle 1? J and H. Which two lines make angle 2? K and H. The ones they have in common are the transversal. That means J and K are parallel. I can write J is parallel to K, and why? Because of the converse of same side interior angles theorem. the converse because I gave you something about the angles and we concluded that the lines are parallel. It would not be converse if I said the lines are parallel and you tell me something about the angles. Okay, number 5. Which pair of triangles is congruent by side angle side? This is lesson 4, or unit 4, lesson 2. So side angle side would be A. Side angle side. This one would actually not even be congruent. This one would be angle side angle. Well, these aren't even congruent because they're not marking the same. This one would be angle side angle. Okay, number 6. Suppose line PQ has coordinates there and line RS has coordinates there. Are those two lines parallel, perpendicular, or neither? This is unit 3. I believe it was lesson 7. This is where I talked about parallel and perpendicular. We need to find the slopes. Okay, so we got to find the slopes of both lines. So PQ, I do y1 minus y2, or y2 minus y1, doesn't really matter. 1 minus negative 5. But I started with 1, so I have to start with 0. 0 minus negative 3. 1 minus negative 5 is 6. 0 minus negative 3 is 3. So the slope of that one is 2. Now we do RS. 6 minus 7 over 4 minus 2. 6 minus 7 is negative 1. 4 minus 2 is 2. So that's the slope of RS. That's the slope of PQ. So those two slopes are opposite reciprocals, so these are perpendicular lines. Slopes are opposite and reciprocal. Okay. So, number 7. If a transversal intersects two parallel lines, what is true about these different angles? So this is unit 3, lesson 1. This was not the converse. These are the straight up theorems. I'm telling you the lines are parallel. What can you conclude about corresponding angles? They are congruent. Same side interior angles, they are supplementary, which means they add up to 180. And alternate interior angles, they are congruent. Okay, this is a proof. We're going to prove two triangles are congruent. So this is unit 4, lessons 2 and 3. Okay? So given PV, actually they're overlapping, so never mind. It's not 4.2, 4.3, it's 4.7. Last lesson in that unit. So I'm going to go ahead and just start with what's given. So PV is congruent to PQ. And I'm going to go ahead and say angle T is congruent to angle R. Those are both given. Now with overlapping, I like to redraw. Even now, after teaching this for many years, I still like to redraw. It's easier to see. PQT and PVR. It's already marked on the picture here, but I'm going to mark them again. So T and R are congruent. PV is congruent to PQ. Okay? With overlapping triangles, there is a piece that is in both triangles, and that would be angle P here. So angle P is congruent to angle P because of the reflexive property. And now I can say the two triangles are congruent. So triangle TPQ is congruent to triangle RPV because of angle side. Back of the first page. Number 9, Q is equidistant from the sides of angle TSR. Find the value of X. This is in the last unit, so 6, second unit, or second lesson. We know Q is equidistant to the sides because those are equal, and Q to SR is perpendicular. The distance from a point to a line is the perpendicular line. So those are equal. That means Q is on the angle bisector, which means these two angles are the same. So then I can say 4x plus, I believe that's 15, equals 27. Find the value of x, x equals 3, and we're done. Okay. Number 10, the following scale drawing represents a bike riding path in a park. If 2 feet equals 3 miles, find x in miles. Okay. So this is the map, so 5 feet, 12 feet. What's x? Let's go ahead and find x just in feet. So it's a right triangle, so I can do 5 squared plus 12 squared equals x squared. And that's 169. Square root x equals 13 feet. We want x in miles though. So now I got to switch that to miles, set up a proportion. So 2 feet equals 3 miles. Oh, by the way, this is unit 5, lesson 1. Setting up a proportion. And we got 13 feet and x miles. So cross multiply. Yeah. So 2x equals 39, x equals 19.5 miles. Okay. So 19.5 miles would be number 10. Okay. Number 11, if triangle STU equals triangle KLM, list all the congruent sides and angles. So this is unit 4, lesson 1. This is just noticing the statement. So now I can say the 6 things are congruent. So angle S is congruent to angle K, angle T is congruent to angle L, and angle U is congruent to angle M. Sidewise, I got ST is congruent to KL, TU is congruent to LM, and SU is congruent to KM. Construct the line that is perpendicular to the given segment through the given point. So this is unit 3, lesson 3. Okay. So with this one, it's going to be really hard because it's small, but I'm going to try it. The way this is going to look on your final is you're going to have to recognize. I can't even get it with the pen doesn't go through the little holes in there. So you have to recognize the markings. So what I just did was I just made the one-eyed smiley. I can't even remember what number I used. I think it was 22. Yeah, 22. And then you would go here. I'd go 22 again. Make a little arc down here. This one, yeah, it's too small. So the intersection is right here. Go 22 again, and wherever they cross, there's your perpendicular line. Okay. You're not actually going to have to construct them. You will not need this tool, but you'll have to recognize the correct markings. Okay. Number 13. List all the corresponding angles along transversal C. So this is unit 3, lesson 1, identifying corresponding angles. Let this be your transversal, so that means we're looking at A and B. What are corresponding on A and B? So it'd be angle 1 and angle 9, angle 2 and angle 10, angle 5 and angle 12, and angle 6 and angle 11. Those are the corresponding angles along transversal C. 14, another proof. We're proving that 2 angles are congruent, so we're going to be using Cpctc. So Cpctc was unit 4, lesson 4. So I see that V is the midpoint of both Ux and Wt. So V is midpoint of Ux and Wt. That's given. What that means is, since V is the midpoint of Ux, that means UV is congruent to XV. But because V is the midpoint of Wt, I can say WV is congruent to TV. And that's the definition of midpoint. All right. now I can say angle UVT is congruent to angle XVW because of vertical angles theorem. Vertical angles are always congruent. Now I can say the two triangles are congruent. So triangle UVT congruent to triangle XVW, and that's side angle side. And now I can say that these two angles, angle U is congruent to angle X by Cpctc. Okay, number 15, write an equation for the line perpendicular to that line that goes through that point. So unit 3, lesson 7 again. So perpendicular is the key thing. The slope of this line is 3. The slope of the perpendicular line is the opposite reciprocal. So switch that, so it's going to be 1 over 3. And opposite sign, so since positive, this is going to be negative. So this is the slope I'm using with this point. So y equals mx plus b. I got the slope as negative 1/3. X is negative 6. B is what we're looking for. Y is 12. Negative 1/3 times negative 6 is positive 2. Subtract 2, I get B equals 10. So I put those two together to write my line. Y equals negative 1/3 X plus 10. Almost done with this first video, 3 problems left. Two similar triangles have base lengths of 3 meters and 8 meters. The area of the smaller triangle is 54 meters squared. Find the area of the larger triangle. This is unit 5, lesson 7. I'm looking for an area. I need an area ratio. I'm given a similarity ratio. I'm given a ratio of their sides. So that's 3 to 8. That is reduced, but that's a similarity ratio. I need to change that to an area ratio by squaring both top and bottom, so it's going to be 9 over 64. There's my area ratio. Now I can find the area of the larger triangle. So 9 over 64. 54 is the smaller, so it's going to go on top to match up. And we're looking for x here. So 9x equals a big number. Divide by 9, and you get 384 meters squared. Write the equation of the line through the point there with the slope of that. So this is actually unit 3, lesson 6. Almost the exact same thing we did up here. Y equals mx plus b. The slope is 1/2. It goes in for m. X is negative 2. Y is 3. We're looking for b. So 1/2 of negative 2 is negative 1. Add 1 to both sides. You get 4 for b. So I get my equation is y equals 1/2 x plus 4. And again, lesson 6 on unit 3, write an equation for the vertical line that contains the point 4, negative 9. So a vertical line always starts with x equals. So it's x equals, and what does x equal in this problem? 4. And that's the end of the first page, and therefore the end of the first video.